Welcome everybody from North Belmont, New York. This is Mr. Cloud coming at you from April of 2020, and we're about to introduce rocks to you. So let's get into it. It's a pretty awesome picture here. I believe this is Mount Erebus down in Antarctica, right? And you see the lava just kind of flowing amongst the snow here. And when we think about igneous rocks, we're going to think about liquid rock. But there are three types of rocks that we need to know about, so let's just get right into it right away. Okay, so what is a rock specifically? Well, a rock, guys, is pretty much an aggregate of minerals. It's a mixture of minerals. That's what it is. So if we take a look at some of these rocks here, some are more obvious than others. But if we take a look up here, here's a pegmatite, and you can clearly see all the different colors there. Those are all different types of minerals. Now, some rocks, guys, are monomineralic. Some rocks only contain one mineral. So there's always these exceptions to the rules, like some evaporite sedimentary rocks are just one type of mineral. But for the most part, rocks are mixtures of minerals. Today, we're going to start talking about our igneous rocks. Okay, there are three rock types. Number one, igneous rock. Number two, guys, sedimentary. And number three, metamorphic. Okay, here's some examples. Down here, guys, this is an igneous rock. What we'll be talking about today, this is called granite. A really common, super common, continental, igneous, intrusive rock. Down here is sandstone, another super common, supremely common sedimentary rock over here. You'll see a lot of that in the Grand Canyon. And then over here, here's metamorphic gneiss, metamorphic rock. So I would say the rarest rocks on Earth's surface. And here's a banded, foliated metamorphic rock. So there are three different types of rocks: igneous, sedimentary, and metamorphic. Today, we're focusing on igneous rocks as we move on today. Okay? So when we think igneous rocks, we think fire, we think flame, we think liquid rock. So that's the first thing that should come to your mind. And the name igneous itself means ignite, ignite the flame. So pretty much what happens is you have liquid rock. It starts to cool. It can happen rapidly or very slowly over a long period of time. But it just solidifies. This is a release of energy. It's a phase change. It's solidification, right? So energy is released and solidification happens. Okay. There are two main types, guys, of liquid rock. Liquid rock found below the surface is called magma. Liquid rock above the surface is called lava. And these are the two main categories of igneous rocks. When igneous rocks form above, right, they cool really fast from lava. And igneous rocks that solidify below will cool very slowly from magma. Okay? And can you guess, guys, here what's happening in these photographs down here? Well, you can imagine if you have lava making its way into cold ocean water, that's going to have a wildly fast heat exchange. Heat's going to be released like supremely fast. Okay, so that's going to be what we call an extrusive igneous rock. And in this case, it's forming basalt, okay, in Hawaii. All right, so before we get into the main categories of these rocks and what they're all about, I want to have a conversation about cookies. I love cookies, and I hope you love cookies too. Cookies are awesome. Okay, down here, we all know that this is, bang, our favorite chocolate chip. And on the right side, what the heck is that, right? It looks like a grandma cookie, right? Grandma would have that cookie, most likely. This is called a Nilla wafer. I want you to keep these images in your mind. Chocolate chip cookie, Nilla wafer. Chocolate chip cookie, Nilla wafer. Why do I say that? Well, I say that for one reason, okay? And it's this. Are we ready? Okay. One reason, straight up. Here we go, right? This guy here is an example of an intrusive rock. Over here, twang. This is an extrusive rock. What the heck am I talking about? Well, put it this way, guys. When you see a rock, guys, that looks like a chocolate chip cookie, it's intrusive. When you see a rock that looks like one of these Nilla wafers, or one of those cookies that doesn't have much texture to it or something like that, that's an extrusive rock. And so what the heck does that mean? Well, just keep this in mind as the conversation moves forward. Okay? I know, I'm so weird. It is what it is. I deal with it all the time. Moving on to the next slide. Here we go. So is there a difference between igneous rocks that form from lava compared to those that form from lava? Of course there is. All right, there are two main categories of igneous rocks that we need to get into. Okay, so this is where you take out your reference tables. So pause the video right here, take out your reference tables, and you turn to página número 6, otherwise known as page 6. Okay, so what I'll do, guys, for you is I'll just Google it, ESRT, or Science Reference Table. Here it comes. And what do? Scroll down, keep going, don't stop, don't stop, don't stop. Here I am. Perfect. Okay, so when we look at this scheme for igneous rock identification, all right, we're going to notice, guys, that we have two main categories, intrusive and extrusive. Let's talk about extrusive rocks right now. Okay, extrusive rocks, guys, are igneous rocks formed above Earth's surface from magma or lava. Magma or lava. Lava, okay, and guess what? They're Nilla wafers. They don't have much texture to them. And the reason for that is that they cool very rapidly. And that rapid cooling doesn't allow for large crystal grains to solidify or really to develop, like in the obsidian that you see here. Okay, so when we look at the reference tables, extrusive rocks will have three main textures. They could be fine, they can be vesicular, or they can be glassy. Okay. I have a link here to a really cool video of pillow basalts solidifying supremely rapidly beneath the surface of the ocean. So definitely take a look at that. Link to it, check it out. All right, the next type of rock here, guys, are intrusive rocks. And you can imagine an intrusive rock, think of them as being insulated with just land and just rock all around the liquid rock. So you can imagine, right? What's going to happen to that rate of cooling? Well, if you have a blanket on top of you, right, you stay warm. And that's what happens here. All right, the liquid rock beneath the surface doesn't cool very quickly. It cools very, very, very slowly. Okay, so igneous rocks, or intrusive igneous rocks, are igneous rocks that form below Earth's surface. We call them chocolate chip cookies. Why? Because they have these massive grains like chocolate chips. Rate of cooling is slow. The slow, gradual rate of cooling allows large mineral crystals to form. The texture that you would see are coarse and very coarse textures. Here's gabbro down there. That's an intrusive igneous rock that's mafic. And we'll find out what that is in our next video series on igneous rocks. Okay? All right. So I'm going to leave you right there with that short, sweet introduction to igneous rocks. In the next video, we're going to talk about, hey, how do we actually identify them? Here's a great link to really start that conversation. All right, to identify igneous rocks in Santorini. 10 years ago, I was there in Santorini on location, and I was at a volcano, all right, with my wife. And we were identifying, like nerds, igneous rocks on that vacation. Thank you very much for listening, and I hope to see you very soon.